This video, we will be discussing about Mathematics Paper 1, Pure Mathematics or P1, 2023, October-November, variant is 12 and the subject code is 9709. For this paper, the total mark is 75 and at around 64 we would get an A star, at 55 we would get A, 46 we would get B, at 35 it would be C, at 24 it would be D, at 13 it would be E, and below this would be fail or U. Question number 1. The coefficient of x cube in the expansion of 3 plus 2ax to the power 5 is 6 times the coefficient of x square in the expansion of 2 plus ax to the power 6. So the coefficient of x cube from this expression is 6 times the coefficient of x square from this expression. So we need to find the value of a. To find the value of a, first of all we need to find the coefficient from this equation, that is 5c3, such that we would get an x cube. Then we have to find the coefficient. For this expression we also have to find the term with x square. Then we need to find the coefficient, and the coefficient of x cube is 6 times the coefficient of x square. After equating we get a value of a, that is 2. 2. We need to find the exact solutions of this equation. To find this exact solution, we first have to rearrange this equation, then just use the calculator to find the value. 3. The equation of the curve is such that dy by dx is given. The curve passes through the point P. Find the equation of the normal to the curve at P. To find the equation of the normal, we need to find the gradient of the normal and the coefficient. We already know the coefficient, so first of all we need to find the gradient of the curve. So after putting the value of x, we find the gradient of the curve, then the gradient of the normal it be its opposite and reciprocal. We know the gradient of normal and the coordinates. Then the equation would be y minus y1 is equal to m in bracket x minus x1. Then we need to find the equation of the curve. As it is a curve, not a straight line, thus we cannot use y is equal to mx plus c or y minus y1 is equal to m in bracket x minus x1. Thus we have to just integrate the differentiation value or differentiation equation. So after integrating this, we get a plus c as extra, as we know the value of x and y. So we put this in our equation and find the value of c, then write the complete expression for y. Question number 4. The diagram shows the shape of a coin. There are 3 arcs AB, BC and CA of a circle where C, A and B are the centers, and triangle ABC is an equilateral triangle. Thus all the lengths of the side are equal, that is 2, and all the angles are 60 degree or pi by 3, where pi is 180 by 3, that is 60 degree. We need to find the perimeter of the coin. To find the perimeter of the coin, we need to find the arc length of any arc and then multiply by 3 to find the perimeter. Then we need to find the area of ABC. So we need to first find the area of the sector, then subtract it from the area of the triangle to find the area of any of this segment. Then multiply by 3 to find the total area of this segment, and then as we know that the area of the triangle, then sum this all to find the total area. So first of all we need to find the area of the triangle, that is this triangle or equilateral triangle, then the area of the sector, then subtract it to find the area of any of the segment, then multiply the segment by 3 and plus the area of the triangle to find the total area. The first, second and third terms of a geometric progression are sin theta, cos theta, 2 minus sin theta respectively, where theta is in radians is acute angle. Find the value of theta. Since it is in geometric progression, so we need to find for a geometric progression, as we need to find the value of theta, and we know that the value of r is equal to third term by second term or second term by first term. That is, we have to divide the third term by second term and second term by first term. Then we divide this and equate both the values of r and then solve it to find the value of theta as given. And since it is an acute angle, that means the angle is in between 90 degree or pi by 2. So this is outside our range, so we ignore this and write our final answer as pi by 6. Using this value of theta, find the sum of the first 10 terms of this progression, giving your answer in the form of a shard. So to find the sum, as it is a geometric progression, so Sn is equal to a in bracket 1 minus r to the power n by 1 minus r. As we know the value of theta from earlier, that is pi by 6, which is an acute angle. So we place the value of theta in the equation of r, that is either in this equation or this equation, to find the value of r. As we know the value of r and we know the first term is sine theta, so we place the value of theta in this equation to find the value of a. As we know the value of a and r, now we can use this formula S10 is equal to a in bracket 1 minus r to the power n by 1 minus r, and then solve it to find our final answer as given. In question number 6, part A, find the coordinates of the minimum point. We know that minimum point dy by dx is equal to 0. So we equate dy by dx is equal to 0 to find our x coordinate and substitute the value of x in the equation of the y to find our x and y coordinate as the minimum point. Then the curve is stretched by a factor of 2 parallel to the y-axis. So the curve is stretched by a factor of 2 parallel to the y-axis. That means it is parallel to the y-axis, and whatever the stretch is, we can see that in parallel to the y-axis, x coordinate would remain the same, but the y coordinate only changes. So y coordinate only changes and is translated by 4 and 1. We know that after the translation of 4, the x coordinate would become negative 4, because whatever the translation is, if it is negative 4, then it will become positive 4. Thus, x coordinate would change its sign, but the y coordinate would remains the same, that is 1. So our initial equation is this: after the stretch of y, that means y stretched by 2, so we need to stretch y by 2, so we multiply this equation by 2, and x is translated by 4, that is negative 4, so x minus 4 square minus 8 x minus 4 plus 5, and after all the y value is translated to 1, that is we have to add 1. Then initially x coordinate was 4, after translation x minus 4 becomes 4, that is x coordinate becomes 8. And for the y coordinate was initially negative 11. After the stretch of 2, it is multiplied by 2 and translation of 1, that means it is added to 1. So our final answer is negative 21. So after the transformation, the minimum point becomes 8 and negative 21. In the equation of the transformed curve, give your answer in the form of given expression. So we know that our initial equation is this: after the after the stretch of 2, we have y coordinate is multiplied by 2, that is y coordinate is multiplied by 2, and we know that the translation is 4 and 1. After the translation, we know that x coordinate always changes its sign and the y coordinate sign would remains the same, that is x minus 4 square minus 8 x minus 4 plus 5, and for the y coordinate it is added to 1 because of translation of 1. Then we expand this equation or simplify this to find our given expression, where the value of a is 2, b is negative 32, and the c is 107. Question number 7, part A, we need to verify left hand side is equal to right hand side. As this is one more question, so this is really easy. So as we can see that we can simplify the left hand side. So we start with left hand side, and after one line we can see that left hand side is equal to right hand side, shown and verified. Prove the identity. To prove this identity, we know that it is easier to solve the left hand side, so we solve it a bit, and after solving we can show that left hand side is equal to right hand side, and hence proved. It is mandatory to write prove here and verified in this 7a. Then in question number C, use the results in A and B to solve this equation. To solve this equation, we know that tan square theta plus 1 by tan square theta minus 1 is equal to the given here in B. So we put this substitution, that is 1 by 1 minus 2 cos square theta in preference to this tan square theta, and then expand this and we come to see this equation. As we know that this equation is in 7a, that is we substitute this equation is same as this equation, so we substitute this value that is equal to this equation, and after solving this we find the value of cos theta, that is 1 by 2. So the value of theta is 60 degree and 300 degree, and for the next value of cos theta we use minus b plus minus root over b square minus 4ac by 2a, and find the value of theta, that is 72 degree and 144 degree. And we know that the value of theta is between 0 to 180 degree, so 300 degree would not be the answer. So the final answer is 60 degree, 72 degree and 144 degree. Also, cos theta is positive in the first and fourth quadrant and negative in the third and second quadrant. Question number 8. The function f and g are defined by the given expression where a is a positive constant. As a is a positive constant, thus it cannot take a negative value. Find the expression for f inverse. We know that the f of x is equal to the given expression. We equal f of x to y and make the x become the subject of formula. After x becomes the subject of formula, we replace x by f inverse of x and replace y by x, and our final answer is given. Then as we know that a is a positive constant and the domain of f of x is less than or equal to a, negative a. As the domain is x is less than or equal to negative a, so the range of f inverse would be the domain of f. So the range of f inverse would be the domain of f, that is f inverse is less than or equal to a. So as f inverse is less than or equal to a, and we can see that it is added to some value, negative a is added to some value, that means the value would be greater than negative a. So it would not be in our range, but the value of negative a is subtracted to some value, that means the value becomes even smaller. And as f inverse is less than or equal to negative a, our final answer also becomes less than negative a, so it would be the answer, while this is outside our range. Find the domain of f inverse. We can see that in the root over form x plus a. So when we write the value of x, that is negative a plus 1, negative a plus a, that is given, we can see that the expression becomes 0. But if we place a value of a that is slightly bit higher than a, that is negative 2a, we can see that it becomes negative a and it is impossible to solve this expression. Thus the value of x can take negative a but cannot take less than negative a. So the domain would be x is greater than or equal to negative a. Then the range of f inverse would be the domain of f. So the domain of f is x is less than or equal to a. So the range would be f inverse is less than or equal to a. Given that a is equal to 7 by 2, solve the equation g f of x is equal to 0. So we know the equation for f of x and the equation for g of x, but we know the equation of f of x in terms of a, and we know the value of a, so we substitute the value of a in the given equation to find the f of x in terms of x only. Then substitute the value of f of x in respective to x in the equation of g of x to find gf of x, then equate it to 0 to find the value of x, that is negative 1.5 and 11 by 2, that is negative 5.5. And as we can see that for f of x we can see that the value of x is less than or equal to negative a. That means the value of x is less than or equal to negative a and the value of a is 3.5. That means the value of x is less than or equal to 3.5. So negative 1.5 and negative 11 by 2, that is negative 5.5. If we compare this two value with the domain, we can see that x is less than or equal to 3.5 verifies this value, but this value is greater than negative 3.5. Negative 1.5 is greater than negative 3.5, so this value is not in our range, so our final answer is negative 5.5. Diagram shows the curve y is equal to this expression and y is equal to this expression as the given expressions. the curve intersect at A and B. So these two curves intersect at A and B. Find the coordinates of AB. To find the coordinates of AB, as we know that both the curve intersect, so y is equal to this expression, y is equal to this expression. As these two equations are in terms of y, so we equate the values of y and find an expression in terms of x to the power 1 by 2. To solve it easily, we substitute x to the power 1 by 2 to y and further solve it to find the value of x as 25 and 1. Then substitute the value of x in the expression any of this expression of y to find the coordinates of a and b. As a comes before b, so the x coordinate of a should be less than the x coordinate of b. So the a would be 1 and 15 and b would be 25 and 63 by 5. We have to find the area of the shaded region. To find the area of the shaded region, we know that the shaded region is in between these two curves. So the area of the shaded region would be, we have to integrate this expression and this expression in limit to 25 and 1. 25 and 1. So we have to integrate both this expression in limit to 25 and 1. After integrating, we found the area of this two area under this two curve, and we know that area of the first curve minus area of the second curve would be the area of our shaded region. So area of the first curve minus area of the second curve would be the area of the shaded region, that is 128 by 3. Equation of the curve is given. Find the exponent of the stationary point of the curve and determine its nature. So we need to find the exponent of the stationary point and its nature. So we know that at stationary point dy by dx is equal to 0. So we need to first find the dy by dx, then equate it to 0 to find the x coordinate. As we get 2x coordinate, so we first find to find its nature, we need to find d square y by dx square. Then substitute these two values of x, and if d square y by dx square is positive, then we would get a minimum point, and if it is negative, we would get a maximum point. State the set of values for which the function is increasing. Since the function is increasing, that means dy by dx or gradient is greater than 0. As the gradient is greater than 0, after equating this gradient that is greater than 0, then to find the critical values of x, that means the values of x that are equal to 0, we find these two values, that is 1 by 2 and 1. And as we can see that for f of x, as the term is positive, since we would have a minimum point. So at minimum point, and the coordinates are 1 by 2 and 1. Since it is greater than 0, so we have to select the region that are greater than 0, that means this region and this region. So this region, that means x is less than 1 by 2, so x is less than 1 by 2, and x is greater than 1. So x is less than 1 by 2, that means this region, and x is greater than 1. Question number 11. The coordinates of point A, P and C are given. Where P is a constant, the line AB is perpendicular to BC. Since line AB is perpendicular to BC, that means gradient of AB into gradient of BC is equal to -1. So first of all, we need to find the gradient of AB, that is y2 minus y1 by x2 minus x1. Then gradient of BC, then multiply it and equate it to -1 and find the value of P, that is 17 and 3. But here we have given that the value of P is less than 10, that means 17 is not in our range, so our final answer is 3. The circle passes through the point A, B and C. Find the equation of the circle. To find the equation of the circle, as we know, the circle passes through point A, B and C, and line AB is perpendicular to BC. That means if we pass the circle through point A, B and C, we can see that line AB is perpendicular to AC, and when the circle passes through C, we can see that if we draw the hypotenuse AC of the line AB and C, we can see that the hypotenuse passes through the center O. As it passes through the center O, that means midpoint of AC would be O. And since it passes through O, that means it is a diameter, and the length of the diameter would be the length of AC. So first of all, we need to find the coordinates of O, that is the midpoint of AC. So x2 plus x1 by 2 comma y2 plus y1 by 2. We know the coordinates of O. Now the length of AC would be the diameter of the circle. So first of all we need to find the length, that is root over x2 minus x1 square plus y2 minus y1 square. Then divide the value by 2 to find the radius. Since we know the radius and the center, so the equation of the circle would be x minus a square plus y minus b square is equal to c square, where a and b are the center and c is the radius square. Then in part C, find the equation of the tangent to the circle, giving your answer in the form of this expression. To find the equation of the tangent to the circle, we know that whatever the tangent is always perpendicular to radius. Wherever the tangent lies around the circle, the tangent is always perpendicular to radius. So as tangent is perpendicular to radius, gradient of radius would be opposite and reciprocal of the gradient of tangent. So first of all we need to find the gradient of radius OC, then we need opposite and reciprocal this value to find the gradient of tangent, and as it passes through C, so it passes through the coordinate of C, so the equation would be y minus y1 is equal to m in bracket x minus x1. So your final answer is given in terms of xd, ey and f is equal to 0 in the form of this expression.